Hello, I hope you are having a great day. Today we are working on lesson 5.3. So we are going to be comparing rates and ratios. So we're going to be seeing who is doing more, who's doing less, which one tastes better, which one tastes like this. So we are going to be using tables and double number lines in order to accomplish that. So let's go ahead and take a look at task 1 here. So in task 1, it tells us that Amari is making orange juice from a can of frozen concentrate and water. The amounts are shown up above. So we are going to make a table to start with here. So go ahead and make sure you have a paper and pencil and are creating this table with me. So we want to create a table to show how much water and orange juice she uses for the pitchers if she makes 1 pitcher or 2 pitchers all the way through 5. So I'm going to start with some labels. I'm going to put P for pitchers, W for water, and let's put OJ for orange. So I need to fill out this table, and we want pitchers 1, 2, 3, 4, and 5. So if she makes 1 pitcher, it looks like she uses 3 cups and 2 cups of orange juice. So every time she's making a pitcher of orange juice, she's doing the same thing over and over again. 3 cups of water, 2 cups of orange juice. 3 cups of water, 2 cups of orange juice. So I want you to see if you can finish filling out this table and then come back and check to see if our answers match. Okay, so I'm saying for 2 pitchers, she needs 6 cups of water, then 9 cups of water, 12 cups of water, and then 15. So there's lots of ways I could do this. 3, 6, 9, 12, 15. I'm just counting by multiples of 3. Or I can say 1 times 3 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So these patterns keep following themselves. So here, orange juice is every 2. So 2, 4, 6, 8, 10. So if she wants to make a pitcher that you make 4 pitchers worth, she would need 12 cups of water, 8 cups of orange juice. So I can use this table to help myself figure things out. What if I wanted to figure out, let's do 9 pitchers. Can you figure out how much she would need of water and how much orange juice she would need without just counting on? Can you see what the pattern is here of how we could find these answers? So I want you to go ahead and try that and then come back and see how I did it. Hey, so I know every time I'm timesing by the pitcher, I've got to multiply it by that basic unit here. So 3 times 9 is 27. So she would need 27 cups of water. And she needs 2 times 9 to make 18 cups of orange juice. So even if we're not just making that list, we just need to times by how many because we're using that set pattern there. That constant rate means that we can multiply to find our answers. Okay, so Amari's chart looks like this. We just filled that out. And she also has a friend, Gabriella, that is making some orange juice as well. But her orange juice is going to be a little different. So it wants us to find the basic ratio of each girl's water. So water first to orange juice for each girl's recipe. So when we're talking about that basic ratio, that means in one group. So for Amari, she needs 3 cups of water. So they put the orange juice first. But the question asks water would be 3 and orange juice is 2. Or I can compare orange juice to water. And then we have water for Gabriella is 4 to 3. Or if I'm going backwards and comparing the orange juice first is 3 to 4. So there's our basic ratios. We cannot simplify these anymore. The biggest number that goes into all of these ratios is 1. And when we divide by 1, we would get the same answer. So they can't be simplified anymore. So now we want to know whose orange juice has a weaker flavor. So we can do that by first, we want to find a place on the table where they use the same amount of the frozen orange juice concentrate. So she's counting by 2, 4, 6, 8, 10. So Amari's only using even numbers. Gabriella uses 3. Amari does not, so it's not 3. Gabriella uses 6. Oh, and Amari also used 6. So I'm just going to underline these rows here. So this is where we want to be comparing. So now we want to know who used more water for that amount of orange juice. So when Amari used 6 cups of orange juice, she used 9 cups of water. When Gabriella used 6 cups of orange juice, she used 8 cups of water. So when we're talking about a weaker flavor, that means it's not going to be as orange juicy tasting. So that means who put in more water to water the flavor down? Well, Amari, 9 cups of water is greater than 8 cups of water. So it looks like Amari's orange juice has a weaker flavor because she used more water for the same amount of orange juice. So you've got to find a place to compare that's the same. I can't compare easily 2 and 3 because they're not the same. But I can look and say she had 6 of orange juice, but then Amari put in more water, so that watered down the flavor and made it weaker. So is there another way we could decide whose recipe has a weaker flavor? So there is. We could actually just compare the ratios here. So Amari's was 2 cups of orange juice to 3 cups of water. And Gabriella's was 3 cups of orange juice to 4 cups of water. So we've written these ratios here. And now we need to compare them. So there are lots of ways we could compare these fractions. We could turn them into common denominators, or I could also turn them into decimals. So I want you to choose one of those ways. So I usually like to use decimals. So I would say 2 divided by 3, and I would say 3 divided by 4. So will you either turn them into decimals or turn them into equivalent fractions or common denominators? So these will be the equivalent fractions with common denominators, and see which one was bigger or smaller there. So, and since we're comparing orange juice, that's why orange juice is coming first. We want that weaker orange juice flavor. So let's look at the decimal or the fractions here. To get from 3 to 12 is times by 4. So 2 times 4 is 8. Remember, whatever we do to the bottom, we have to do to the top. To get from 4 to 12 is times by 3. So 3 times 3 is 9. So 9 is greater than 8. So this is saying hers has a stronger flavor because it's bigger on the orange juice. Hers has a weaker orange juice flavor. Let's see if our decimals tell us that same thing. So 3 can't go into 2, but it can go into 20 6 times. And 4 can't go into 3, but it can go into 30 7 times. 0.7 is bigger than 0.6. So again, it's telling us that this flavor was stronger. Gabriella's flavor was stronger. Amari's flavor was weaker. So you can either find a place that is the same, or you can just compare their basic ratios. So let's go ahead and complete task 1 here. So you're going to fill out Amari's table and then tell me about Gabriella's orange juice. And then we're going to compare, like we did, find a place where they were the same, and then tell me who used more water. And then for the turn and talk, you're going to tell me a different way you could have compared their orange juice flavors. So go ahead and pause the video and then come back when you're ready to do task 2. So task 2 has Mrs. Morales is teaching computer programming. Each student writes an average of 9 lines of code per hour. So every hour they wrote 9. So after 2 hours, that would double and be 18. So go ahead and pause and see if you can finish the table for Mrs. Morales' class. Okay, so 1, 2, 3, 4, 5, 6. This is just counting by each hour. And then every hour they do 9 lines of code. 9, 18, 27, 36, 45, 54. So a pattern I notice is they're doing 9 every time. So 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. So if I wanted to figure out how much they did in 12 hours, I would times that by 9 and get 108 is how much they did in 12 hours. So every hour is 9. So we're just multiplying by 9 each time. So Mrs. Sanchez also teaches a computer programming class, and each of her students is able to write an average of 4 lines every 20 minutes. So Mrs. Morales' class did 9 lines every hour, and her class is doing 4 lines every 20 minutes. So as they are right now, we're comparing minutes and hours. We are not comparing the same thing right now. So we can't just look at their chart and we can't just go to this first one and say, oh, they do 4 and they do 9, because they only had 20 minutes and they had a full hour. So we can use this chart though to find their hour. So if I'm counting by 20s, 20, 40, 60. So if I have 60 minutes as an hour, it takes 1, 2, 3 sections of 20 minutes to make an hour. So they turn 20 minutes into a third of an hour, because here's 1/3, 2/3, 3/3 is a full hour, because 3 divided by 3 is 1 full hour. So after 20 minutes, they did 4. After 40 minutes, or 2/3 of an hour, they did 8. Here's 3/3, they did 12. So each time just getting 4 times bigger, 4 times bigger. Then here is 4/3, which is 1 hour and 20 minutes, because it's 1 and 1/3. 1 hour, 20 minutes is 16. 1 hour and 40 minutes is 20 lines of code. And then 6 divided by 3 equals 2. So after 2 full hours, they did 24. So we want to know whose class is doing more coding each hour. We need to compare their hours. We've got to compare the same thing. So I can look on Mrs. Morales' class, and here's 1 hour for her class. They did 9 lines of code. This is only 20 minutes. This isn't a full hour. But 3 divided by 3 is 1. Here's the full hour. And after an hour, her class did 12 lines of code. So whose class is doing more? Mrs. Morales' did 9. Mrs. Sanchez's class did 12 in an hour. So Mrs. Sanchez's class is doing more lines of code each hour. So you've got to make sure that you're comparing the same quantities there. So let's go ahead and look at task 2. So task 2, you're going to complete Mrs. Morales's double number line. And then you're going to see how much Mrs. Sanchez does in an hour and tell me whose class is faster. Hey, that is everything for our lesson today. So you're going to complete your check for understanding. And if you have any questions about comparing these rates and ratios, please let me know and we can set up a time to meet.